For over half a century, people have turned their eyes skyward, wondering if Earth is the only cradle of life in the vast cosmos. This question, one of the oldest and most profound, has driven scientists, dreamers, and explorers to peer deeper into the night sky. Among the many celestial bodies that have captured humanity's imagination, one stands out for its tantalizing proximity and potential: Proxima Centauri b. This small, rocky exoplanet orbits Proxima Centauri, the closest star to our solar system, just 424 light-years from Earth. Discovered in 2016, Proxima b has stirred excitement due to its position in the habitable zone, where temperatures might allow liquid water to exist on the surface, an essential ingredient for life as we know. Despite its potential, Proxima b is far from Earth-like. It orbits a red dwarf star, a type of star known for its instability and violent solar flares. These flares bombard the planet with radiation at levels hundreds of times greater than what Earth experiences. The planet is also likely tidally locked, meaning one side is in perpetual daylight while the other remains in eternal darkness. This makes Proxima b an alien world, with one hemisphere scorched and the other frozen. Yet it's precisely this strangeness combined with its closeness that has made it one of the most closely watched targets in exoplanet research. The search for answers took a dramatic turn with the introduction of a revolutionary artificial intelligence system called Grok 3, developed by XAI. Grok 3 is no ordinary machine. It's a next-generation analytical engine, capable of processing and interpreting petabytes of data that would take human scientists decades to analyze. It was designed to detect subtle, complex patterns buried within the vast noise of astronomical observations, and its creators hoped it would clarify the nature of Proxima b's atmosphere, surface conditions, and potential for life. When researchers fed Grok 3 a mountain of observational data, light spectra from the Very Large Telescope, atmospheric simulations based on readings from the James Webb Space Telescope, JWST, and radio signals gathered by the Atacama Large Millimeter, Submillimeter Array, ALMA, they expected refinement, not revolution. At first, Grok 3 delivered as expected. It confirmed Proxima b's orbit at approximately 0.04856 astronomical units and reinforced existing models suggesting that the planet might have liquid water along its twilight zone, where day transitions to night. Then something unexpected happened. Within the dense layers of light emissions analyzed by the espresso spectrograph, Grok 3 identified a repeating infrared pattern. Initially dismissed as interference or background noise, the signal didn't go away. When cross-checked against known astrophysical processes, Grok 3 detected a mathematical consistency, harmonic intervals that repeated with unnatural precision. This alone was enough to raise eyebrows. But Grok 3 didn't stop there. Further analysis of ALMA's radio data revealed a series of pulsed emissions, faint rhythmic signals radiating from the dark side of the planet. These weren't your average bursts of static or energy spikes. The pulses appeared to be synchronized with the infrared pattern and exhibited a fractal complexity, a self-similar structure seen in nature only in living systems or human-created codes. There was nothing random about these emissions. They carried structure. They hinted at design. This was not just a strange anomaly. It was something new, something entirely outside the scope of known physics or geology. Even more startling were Grok 3's findings regarding Proxima b's atmosphere. Previous theories suggested that the planet's atmosphere, if it existed at all, would be thin and stripped by constant radiation, likely dominated by carbon dioxide and nitrogen. However, Grok 3 detected the spectral signature of an unknown compound, a molecule absorbing light at specific wavelengths not associated with any known gas. This compound wasn't static either. Its presence fluctuated dynamically, particularly around the planet's terminator zone, as if influenced by some external mechanism or stimulus. What could possibly explain these phenomena? Some scientists suggest a natural geological process, perhaps volcanic activity or deep subterranean chemical reactions, could be producing electromagnetic signals. Imagine a superheated ocean of magma beneath a crystalline crust. releasing pulses as it shifts and flows. It's an exotic but conceivable scenario. However, it fails to explain the precise mathematical structure of the observed patterns. Nature can be chaotic, even rhythmic, but rarely disordered without external guidance. This leads to a far more provocative and controversial theory that the signals might be artificial in origin. For decades, the scientific community has debated the concept of technosignatures, evidence of advanced civilizations in the universe. These could include everything from the manipulation of a planet's atmosphere to the transmission of encoded signals across space. The patterns Grok 3 has identified bear an uncanny resemblance to these hypothetical constructs. Could Proxima be the site of long-abandoned alien technology, still sending out signals as a kind of cosmic lighthouse? Or worse, could something active still be there? This possibility, once the domain of science fiction, is now being seriously considered. NASA, the European Southern Observatory, ESO, and major space agencies around the world are rushing to validate Grok 3's findings. The JWST has been reoriented to focus on deeper spectral analysis of the strange atmospheric compound. ALMA has increased its observation window on the Proxima system, and the upcoming Square Kilometer Array, SKA, the world's largest radio telescope network, is prioritizing the confirmation of the rhythmic radio pulses. Teams of astronomers and data scientists are also working to independently verify Grok 3's conclusions. New algorithms are being written to cross-check the AI's pattern recognition. These efforts aim to ensure that the results weren't distorted by a glitch or anomaly in the software, a necessary step given the monumental implications. If even a fraction of Grok 3's discoveries are validated, we may be standing at the edge of one of the most important moments in human history. It could mean that we are no longer alone, that somewhere out there, even on a scorched and frozen world orbiting a distant red star, intelligent life, or its remnants, once existed and perhaps still do. At the very least, Grok 3's findings suggest that Proxima b is not a dead rock, floating in the void. It may be geologically dynamic, atmospherically complex, and potentially capable of supporting life in its twilight zones. The idea that such a place could host even microbial organisms is breathtaking. The notion that it might be the source of engineered signals, deliberate messages crossing light years, shifts our understanding of the universe entirely. For those who have lived their lives with one eye on the sky, hoping for a sign, this may be it. It is a moment filled with awe, wonder, and a touch of fear. Because with discovery comes responsibility, and the realization that if we are not alone, we must reconsider everything we thought we knew about life, intelligence, and our place in the grand cosmic story.